but let's move on to the next presenter. I'm just going to do a quick screen share. So we're very lucky to have with us Andre Gauthier. Did I say that correctly? All right, cool. All right, so Andre is a bit of a legend to be frank with you. I mean, he's contributed to so many things, right, including the dots architecture at Unity, FBX. Then we're going to hear a lot of lessons learned about that today. Motion builder, a ton of work in animation and inverse kinematics. And Mark and I were very privileged to have him on the podcast recently, which just came out yesterday, that episode. So just a shameless plug for that episode. And with that said, Andre, I'll stop sharing and you could do a share and take it away. Yep.
So hello, everybody. So I'm sorry, it will be a bit of a clumsy conversation or presentation. I'm not sure, I haven't been part of those conversations with this group in the past. And so, and I know there's tons of knowledge there that's already there. So what I hope is I'll be able to share some of the experiences I had, but some of it may already be known to all of you or be maybe irrelevant. So I'll try to be as relevant as possible as I go. And then please, hopefully we'll have a conversation after that. So I'm Andre. We've done FBX so at the beginning of my career and then a while at Autodesk. And FBX was born out of a film box. And the idea of FBX at the beginning was just create a format for film box to be able to read data, and then it expanded over with a lot of time over the years, an imperfect format. So what I want to talk is my experience, because we had to run kind of that group for a while at Autodesk and at Alias, and so some of the problems we had to encounter and solve. So I'll try to share that. So I was looking at USD. I was super happy with USD because it actually it solves something FBX wasn't solving at all. So everything related to this whole idea of non-destructive editing and layering and referencing content and object models related to that is extremely powerful, and it's needed for all the pipelines, and every pipeline that we know does have some of that. And then inside the USD, there's also a part where there's standard schemas and stuff that are common. So USD, in the case of the studio, the standard stuff then ends up, you can kind of manage the teams, what they're using and not using. In the case of FBX, we were kind of an open format for everybody. So we had to kind of deal with what it meant to do actual interrupt as the main function of it. So USD is moving into it and does some of it. FBX was kind of there. Obviously, this is an imperfect world, but I'm making a difference between kind of the idea of interchange, or we talked about, bidirectional interop or ping pong, whatever that is, or consumption. So you publish for consumption somewhere else. And they're quite different problems. So FBX was confused about those things at the beginning. So because what we were trying to do is represent the information that we had. So we're essentially transferring the authoring representation. But when you start transferring that, you kind of create a load on the other recipient side of the thing to be able to understand that form. So if you don't understand it completely, then you'll do crap with it, essentially. So you have a benefit because you have actually high-level authoring information. So in our case, and I'll give some examples, but nerves and different aspects of that. But what we realize is mostly people consume transform content, because most of the package don't understand the actual authoring content in a real way. So how do you solve that problem? And in the case of FBX, we have to kind of deal it by putting that functionality inside the SDK. So I'll talk a bit about it. I'm not sure if it's the real long-term solution, but it is something we have to deal with. So the more you want to be thorough about the original data, the more you're abstracting the information. And so I gave a few of those examples, but one really, really good example is a nerve trim nerves, for example. So it means if I'm able to represent surfaces in that realm, and past, I don't know, 20 years ago was important to transfer nerves because people still use them. But we were able to transfer that. The problem is most of the consumer could not deal with it. They didn't know how to be trimmed. They didn't know how to actually tessellate that information. So the fact that we transferred the authoring information was creating a lot of difficulty for the people on the receiving side of it. So what we ended up doing is I had to package inside the SDK most of the translation. So because either you transform at the publishing side of that, in which case you're lossy, so you lost actually authoring information, or you have ways of transferring the information downway. So GLTF, for example, is a version of consumable, content, but it has lost kind of the authoring complexity of where that comes from. So understanding where we sit and where it is, I think it's important. So for FBX, we had to deal with that. So another field of view focal length. So it's one detail, but I mention it because we'll talk about the animation a bit later, but it means that everybody reading it, if you ended up writing field of view instead of focal length, and your package is understanding the world in focal length, then it means you need to translate that and you need a film back conversion, and it can be quite error prone. So essentially people do make mistakes on small details, but it's true. We have the edges, smoothing groups. Anyway, there was tons of reasons where we actually had to deal with the conversion. And if we didn't, it was creating a problem for the users. I'll talk about animation because I know so I've been told that there's conversation about curves and curve conversion and curve in the format in USD and moving curves. And the actual curve problem was actually the simple problem. Even though you have to agree on all kinds of things, how you represent tangents and what you do with it, are they stretchable, not, or whatever package is dealing with that. But you end up in a mess really, really quickly, especially when you start hitting the transform universe. And I'm mentioning that, so some of the examples here are rotation order pivots, Z up, Y up, left and right hand, something. So essentially, if you end up animating the translation of a pivot of something that is rotated against a Y up universe, well, it's interesting when you write it, but when you read it, it means that if you're not in Y up and you're in Z up, or the pivots are different, something, then you need to do something about the curves. Not only the data itself, so you need to transform it, but then also meaning what is animated. And when it's linear conversion is good, but when it's non-linear, then tangents goes to crap, and then it means that you need to resample the information. How do you do that? And I'll give examples. We have to deal with Euler transformations. You end up rotating with rotating pivot. You get a Euler, and then you need to resample. Then you end up in Gibel-Lex. You end up with tangent errors. All kinds of things that need to happen in order for the information to be understood. So, as I was looking at the USD standard, it's quite open relative to how you want to deal with representing transforms, and it's normal because you want to remember the authoring aspect of it. But it means that when people actually do the consumption of it, they need to be extremely, extremely talented in order to interpret it in the right way. And so in our case, we had to put a lot of that logic in the SDK. And it needs to be somewhere. It needs to be available to people so that people can do the transformation. So we need to think about that. But yeah, this is something we have to deal with a lot. And the domain of animation, there's baking, there's all kinds of details in there. We also experimented with something called human IK. So because this is interesting, we're saying, oh, okay, let's author content that is higher level. So we talk about characters and solvers and something. So we have that challenge. So we decided that between Max Motionville and Maya at Autodesk that we would share those things. It was great because we could have all the characterization information. We're able to transfer that, but it broke easily for kind of a bizarre reasons, because solvers, you get to upgrade the solvers as they change over time, and they may have different parameters, a detail, but if there's nothing that looks less like the same result than the same result with a different parameter, and so we ended up having a problem of managing the staggered release of all the the packages. So Max would release, and then Maya would release 6 months later. And then if the character is incompatible, then the data needing to go between those two packages was something we had to deal with. So I'm mentioning that because I know that there are conversations around kind of higher level character constructs and solvers and moving into the metaverse side of that thing. I have quite a lot of thoughts around this, but I'm sharing kind of the problem set. Then I go into the plugin writing thing. So, and I know that USD has some of those challenges and all of that. So the more complicated the plugin is to write, the more chance people will write it wrong. So, and generally on the output side, they're pretty good. They're pretty good, but they're generally not interested. So most people are not interested in their exporters because it's for other people. They're extremely interested in their importers because they're bringing data inside the package. Obviously, it's not that trivial, but in terms of effort, I saw that often. So people would often export maybe wrong data or incomplete data. And also when they had to create the importers, they were as good as the content they could test with, because they had to understand the data in a way that is extremely elaborate. So again, over time, what we ended up doing is pushing those problems into the SDK to make sure that we're able to convert the data in a way that is simpler to write. It is something to think about. So what is it to write a standard or an easy plugin, and now how level complexity go relative to this? And this was something we're struggling with. At Autodesk, we had plugins for Max Maya, for Auto Studio, for AutoCAD, for Revit, and then other sub-products, but we ended up having to deal with all those multiple, plus the third-party market, so everybody else that were using the FBX and trying to transfer the information. So we had to survive through what it meant, and we had to manage the fact that most productions don't upgrade their packages. They keep certain versions of the software at certain versions. So in order for us to be able to do that, we needed to mind quite a few things. We needed to be able to release different versions of the SDKs and plugins against multiple versions of the products. In our case, it was our own, but also helping our customer to be able to do that. So that would include, multiple Maya versions, multiple SDK versions, and multiple file versions, because you actually want the content to be there to be ingestible, the past content to be ingestible by future packages. So, so it was multidimensional. So we ended up having to kind of create ways of building those. And because you're in an open format, there's also a lot of it that you don't control, that's outside of you. But at least you need to make sure that your standards are kind of thorough. So which brings me to what we had to do in order to survive. And we created an extremely elaborate testing infrastructure where when we would release any new SDK something, it would actually build versions of plugins against multiple versions of the authoring applications. Testing with multiple versions of content, and then actually do render tests in our case. So it was image compare, it was also data comparison, but to make sure that we wouldn't break things, because at the beginning we didn't have that and we were breaking things all the time. As you're trying to evolve and go further and further into what we're trying to do, we kind of had to deal with it. So how are we integrating older versions of the data? How do we convert it? Was something we have to deal with. So that's another aspect, and also something I will happily discuss, and but it's something we have to deal with in order to kind of improve the quality of what we're trying to do. So in the recap part of that is authoring data. Yeah, so if we want to transfer authoring data in the right way, we need to have transformation as part of either the SDK or something that allows for people that don't understand the authoring data as it is into something that they can understand. And we need to segment the contract and need to know somebody, this is the part of the data you need to understand if you want to do this, or if you want to understand nerves, this is what you need to understand. So be clear about it. And I heard a lot of you talking about some of those standards, related to materials. So that's true for that. That's true for, I would say, all parts of the interop pipeline. be mindful of how difficult it is to write a plugin and make sure that we help the plugin creators to be able to actually do what requires to do. And the testing framework, I think you can deal with it for a while, but what happens is if you don't, it's easy to have actually broken implementation relative to the content. And that's what we have to live with. So I'm mentioning that one last thought. It's just it's something that was discussed. I know that NVIDIA is doing some of that, but we actually need to think about those things as services. Often we provide formats and provide an SDK. There's quite a few challenges with SDK. So if you look just the USD SDK, if I'm a game, I was working at Unity for 10 years, so we had to, if we wanted to use USD on devices, then we have to compile this whole thing against, I don't know, Android or some kind of VR device. And this was almost impossible to do, so it's because you need to carry so much context and plus everything related to runtime kind of you kind of want to segment and provide the data in something a bit more differently. So it's a bit of an overcomplicated drawing that I did there, but I think thinking about where we want to move those standards outside of the standards, also the SDKs, and the fact that we have SDKs more as services, I think is something to think about, because it allows us to actually create transformations, be able to make the content, survive multiple versions without having to deal compiling with every application everywhere. So there's really some thoughts that I think that would be useful in that area. Yeah, and so that's it for me. Yeah, so open for questions.
Awesome, really cool presentation. It's so amazing to see kind of all these lessons learned, and then your forward thinking here that I think probably aligns with how many folks are thinking about this. So I'd love to open up for questions.
So I'm trying to unshare. Give me one moment. My the window is okay. Good.
Who has the
Well,
first?
thank you for the FBX SDK. Used it, I don't know, probably to convert almost like 100,000 more files, and it worked really well. So, like, while you had a lot of challenges, it actually did work.
Other questions or comments?
There is a big philosophy difference. Oh, go ahead.
Oh yeah, I was just gonna say, do you want to go into a little bit more detail on what you were talking about with regard to transformations and tangents and all that? I wasn't completely clear about what it was you were referring to.
Okay, so but the exchange, the challenge, for example, is if you got some animated models or a series of models, and you keyframe those keyframed models. So essentially, you have a curve that animate some of those parameters, and you have a collection of those across multiple models. And then it makes sense in the authoring package. When you want to interpret that and then bring that animation somewhere else, then what happens is if the context for the way things are described changes, then you need to be able to transfer the animation data in a way that makes sense for the receiving app. So one example would say Y up, Z up. So it means you need to rotate the world completely. So all your rotations are, for example, 90 degrees shifted in some context. So in order to deal with that, then you need to transform the keyframes and then transform the animation themselves. And sometimes just that transformation is not in a way that you can just move tangents and move keyframes, and you need to resample. Because if not, then you're actually losing information.
So in your particular example of changing Y up, you could just take the whole thing and put one transform on top of the whole thing.
Yes,
but there's another. You're interested. You're referring to some more what? Oh,
but we did so, and then there's left-handed and right-handed, and then there's pivots, and then there's rotation offsets that some packages do support and the other doesn't, and then you either add new models, in which case you transform it. When you re-export, then you add new objects, so there's all kinds of variations, and I'll be happy to discuss all kinds of reasons why we had to tackle some of those.
Yeah, I mean, I think it would be actually pretty interesting to see a catalog of the specific cases that are, and what they involve.
Yeah.
I think that as a kind of, I don't know, a guide to a minefield of the future for USD.
Happily.
Yeah, I would love to see that.
One given example is scaling inheritance, for example. So the fact that scale is inherited from one model to another. So you scale the parent, the children will be scaled, and then there's different ways of propagating scaling. Some non-uniform, some uniform, and then if the scale inheritance wasn't enabled, then you needed to counter scale animate the children. So that's one other example. But there's many of those, which end up kind of making life a bit of a problem.
Right. Yeah, and I think it would be very valuable to, sort of have that list and have the USD folks go over that list and ask, how well USD is currently addressing each of those things and whether some of them need more attention.
Yeah, Michael, I think this is the essence of this conversation. As we are about to tackle more animation in our world, how do we bring in, all that experience, all the learnings of a FBX without losing? So I think we'll have to think about, I don't know if it's another subgroup or something. When do we want to tackle it? Are we ready to tackle like animation curves, and are we willing to put our finger into that animation agenda? I think we have to. I think personally, my opinion is the sooner the better. I don't know what others think, but it's we'll have to transfer most. I mean, we bake everything. I mean, especially in the world of Unreal Engine right now, we use Alembic and baking or USD baking. So we've worked around the issue in the film pipeline and in a bunch of pipelines. We've worked around that issue. I think it's we'll need to tackle it soon. So that
and NVIDIA Machinima has a solution for animation curves, and we invite people to take a look at it, suggest improvements, changes. We're happy to have that evolve into something that a lot more people use, and that becomes somewhat standardized, and addressing the kinds of issues that Andre's bringing in, in that context would be very valuable.
One of the challenge of that, and what you're mentioning is this. So once you create a standard, there's also, I'll call it a combinatory explosion. So essentially, the more you add nodes to that network, and everybody has some kind of variations of that representation, but if everybody has to deal with the complexity of everybody, then you never reach any kind of actual working, because it's always somewhat broken. So it means you need to kind of centralize the conversions in ways that either through code or through services, whatever that is, so that it becomes consumable for everybody. And then the logic, because not a lot of people have actually animation expertise. So a lot of some, but the details of it requires a lot of nuance and something. And if you require for everybody to have that knowledge, then it's failed. It will fail. So essentially, that's kind of the idea, is to bring that knowledge into code that does the transformation for you and then brings it in the way that is needed. So what I would love to make sure is outside of actually understanding problems, is try to actually extract and make sure that we have that code somewhere that does the needed work, so that it makes sure that everybody can consume the information.
Right. Do you want to talk a little bit about the experience with NURBS? Who used it? Where was it important? Did it matter whether it was the tessellations were watertight? Did you keep topology?
Yeah. So again, it became tons of parameters, and the people that actually cared about the NURBS themselves, because we were transferring action NURB information from one package to another, and they actually needed and were able to deal with actual trends and where it is. In the other side, what we ended up is when we were with Alias, we ended up using their tessellation libraries as part of the SDK. And then where you could, as part of the import, decide how you would, do the conversion and the tessellation using, solving surfacing and all those things that were used by actual Audio Studio. So we had to bring that in order for people to do that. It got less and less used over time because nerves were more specialized, and then people ended up kind of dealing with those in a different way, and they would do their own tessellation. But at the beginning was quite a lot. It was used before subs were extremely,
Popular, yeah.
standardized and everything. Yeah. But it's kind of an illustration of the problem itself, which means if you get parametric surfacing or parametric representation, then you need to understand that, and you need to be able to convert that in a way that is understandable by the destination package.
But did you ever do like a full BREP with complete topology information? Not only here's a bunch of nerves, but here's the way they're connected, and because these ones are connected, when you tessellate on one side, you have to match it on the other side, et cetera, et cetera.
Yeah, and so at some point we said stop, and then because it was a diminishing return essentially. But it means that if we go into that realm, and some did, so there was a product called Direct Connect by Alias that was doing some of that representation, and that actually that problem, they were more tailored for CAD information and solid modeling. But it also means that when you start to want to endeavor in that area, then it means that you need to have the conversion and the publishing ability to do exactly what you're trying to do. And when do you do it so that the data is actually consumable on the other hand?
Ben, did you have a question from a few minutes ago?
No.
Michael, do you have more questions?
But yeah. So hopefully it was useful. I would engage with anybody if you want to. One thing that I mentioned, Mark and crew, is, and I will obviously Eric is not there today, but Eric Bourque from Autodesk. So it's something I want to engage with is, can we extract some of those algorithm solvers out of what we've done in the past and make that available to what we're doing right now, and where should transformation happen in that universe, in the USD universe? Maybe have conversation about it. You want it as late as possible for consumption to make sure that you keep more of the original information, but you want it at the right place when you need to consume the data and you don't need the knowledge. So anyway, so I'll engage with Eric also in some of that, but it's something that would be useful for you and people. This is something I would love to discuss.
And maybe we need to get you back, Andre, when we talk about animation, because we discussed that. I don't know if Guido is there today, but there's a bit of appetite for behaviors. There's another group that has a strong appetite for characters and skeletons. And one thing that at least from my perspective would be important is, let's make sure we get curves and transformation right as a foundation, and we agree that that we are there, or if there's changes to be made, so that we can then start tackling those more complex problems, and and effectively skeletons. One is to have a characterization, the other one would do we need to solve? I mean, should we try to get a reference solver so that that you get interoperability? So there are a few more conversations to be had. So I think it was important to kick it off today, but we haven't started those conversations. We were deep. You see us, we're advanced on materials. There is some conversation around physics, and again, we're going to have to ask ourselves, when do we start tackling those animation things? So, but at the very basic transformations and curves first, and then build it up from there all the way to rigs and all those cool things we want to do ultimately. So, do you agree with that, Michael?
Yeah, I think so.
Cool. Then I'll just do a last call. Was there any quick Q&A for Andre? Okay, well, Andre, again, thank you so much for coming.